This is the first of a series of 3-minute mathematics videos that I'm going to create for you. This one's talking about distributions, and the question that we're going to go through here is typical of the kind of question you might get, where the answer is just going to be, do you understand the distribution? Do you understand what's going on? Let's take a look at the question. An insurer wishes to estimate the expected number of claims, lambda, on a particular type of policy. Prior beliefs about lambda, we're told something about lambda, is that it follows a gamma distribution. Gamma distribution, do you know what a gamma distribution is? Do you know where to find it in the tables? We're given the density function for that. We can look at our tables to see what parameters that means this gamma distribution actually has. Now, we're asked to estimate, for an estimate d of lambda, the loss function is given by this formula. So we have a loss function which is written in terms of lambda and d. So our estimate of lambda is d, and this is the loss function, lambda minus d all squared plus d squared. We're asked simply to show that the expected loss is given by, and we're given the answer. So this is a typical question, pretty straightforward because we're given the answer, we know what we're trying to get to. But how do you try and solve this? Let's take a look at the solution. Well, first thing is to note that we're given the loss function. It was lambda minus d all squared plus d squared. To work out the expectation of that then, straightforward, we want to work out the expected value. We write that as the expected value of lambda minus d all squared plus d squared. And then, in the second step, we expand this formula. Lambda minus d all squared is the same as lambda squared minus 2 lambda d plus d squared. And then we have to add on another d squared. Rewriting that, remembering that lambda is what we're trying to find, d is known, d is the estimate, we can expand this to be the expectation of lambda squared minus 2d times the expectation of lambda plus 2d squared. So our next stage is to work out, well, what is the expected value of lambda squared and the expected value of lambda? Well, we're told lambda is a gamma distribution. It has parameters, alpha and beta. We work that out by looking at the gamma distribution we were given, linking that to the formula tables, gamma distribution. Looking at the tables, if we have a gamma distribution with parameters alpha and beta, the expected value of that lambda then is alpha over beta, the variance is alpha over beta squared. Now we needed to calculate the expected value of lambda squared. We can write that down by knowing that the expected value of lambda squared minus the expected value of lambda all squared is the variance of lambda, and we know the variance of lambda. So that means the expected value of lambda squared is the variance of lambda plus the expected value of lambda squared. That is alpha over beta squared plus alpha squared over beta squared. Finally, we just need to substitute these in now to our loss distribution to come up with the formula.